This is example 12-12, flow over a triangular sharp crested weir. We see our triangular shape right here. And so we have the flow going over this triangular cutout into that plate. We're given the overall upstream depth, and we're given kind of where the tip of the cut in the plate is. And we are asked to find out what the volumetric flow of water passing over the weir is, and we're given our coefficient. So these types of weirs are very commonly used to measure flow. So you can imagine that there's a scale on the side here that tells you exactly how deep it is, and then you can just look out the window, see what the depth is, and you know what the flow is, right? So, well, how do we do that? Well, use the equation that we found, right? It was Q actual, start a little high, CD times 8/15 times h to the 5/2 times tangent theta, it's the opening, times square root of 2g. Well, all we have to do is plug in numbers. This one was a pretty straightforward one. Right, so we're given CD is 0.72, 8/15. Then the height, right? Remember that the h is just this part right here. Right, so we have to do 2 meters. 2 meters minus 1.6 meters. And that is all raised to 5/2 times tangent. Now the overall angle is 60, but we're only interested in half the angle, so that would be 60 degrees over 2, and then times 2 times 9.81 meters per second squared. All right, plug all those numbers in. We get 0.099373 cubic meters per second is equal to 9.94 times 10 to the minus 2. Let's make sure that we can actually see the minus 2. Why that back doesn't work at the moment, but we can erase. Minus 2 cubic meters per second. Right, so again, this type of weir is used very commonly to figure out what flow in a channel is. You can just build a little plate in there, and then measure what the depth is. And again, you can measure the depth easily. You can just have that kind of marked out along one of those, or you can have a floater or something like that to make it easy to measure the depth.